So we're still in the review, lesson 4.6, the mixed equations, and we're going to play with the volume of a sphere. And let's see, so we have this formula, 4/3 times pi times the radius to the third power. Units must be consistent. If the units are kilometers, what are the units of the volume? So let's write this down. This again is number 20, lesson 4.6, and we have the volume is 4/3 times pi times the radius to the third power, and we're told the radius is going to be measured in kilometers. Kilometers is abbreviated km. And if I take any measurement in kilometers and plug it in for the radius, that's a 4, believe it or not, 4/3 times pi times kilometers to the third power means I have kilometers to the third power, which are sometimes called cubic kilometers. So velocity, the volume is going to be measured in what we call kilometers cubed or cubic kilometers. And for that, try to imagine, it's pretty big, but measuring out 1 kilometer in one direction, and then perpendicular to that, measure out 1 kilometer, like maybe straight up. And then straight back, measure another kilometer. And then imagine this giant cube. All right, that's the best cube I got for today. That measures 1 kilometer by 1 kilometer by 1 kilometer. So that's what the results of this formula are going to give us. And then, so cubic kilometers, we want to solve this for R, and we have to figure out which is the correct formula here. And then we have some big numbers to plug in to either the original formula or the modified formula we're going to get in part B. So let's solve. So whenever we solve for a variable, in this case the R, we usually work on getting things that are furthest away. So I need to get rid of the 4/3. And whenever you have a fraction that's a multiple, the easiest way to get rid of it is to multiply by the reciprocal. So that means flip that fraction and multiply by it. So I am going to multiply by 3/4 on this side and 3/4 on that side. And the point is, this gives me 12/12, which is 1. The 3's divide out, and the 4's divide out. So the only thing left on the right side is now the pi times the r to the third power. On this side, I could view that as v over 1, and so I could call that 3v over 4. Or I could leave it as 3/4 v. Either way is fine. To get rid of pi is just a number, it's being multiplied, we'll divide to break the multiplication. So to undo multiplication, we have to divide. So I have to divide that fraction by pi. The point of that is a number divided by itself is 1. 1 times r cubed is just r cubed. On the other side, I'm going to clean that up a little bit more because they don't have anything that looks like that in their suggestions. So when we take a fraction and we divide, division with fractions means multiply by the reciprocal, which means flip the fraction you're being divided by. So I'm going to take my 3v over 4, and I'm going to multiply by, instead of dividing by pi, I'm going to multiply by 1 over pi. When we multiply it straight across with fractions, so 3v times 1 is 3v, and then 4 times pi is just 4 times pi. And then the last step here, excuse me, is to get rid of the cube. And to get rid of a square, we take a square root. So to get rid of a cube, we take a cube root. So then I apply a cube root which looks like a square root with a little 3 hanging in that notch. And the point is the cube root and the cube cancel. So cube root cancels the cube. So that on the right side, I just have r, and r is equal to this thing right here. So then you would just find your version of that, and you might have it in a different order than mine. So I want cube root, and the 3 should be in the top. So for me, it's this second one. All right, next, the moon has a radius of about 1,738 kilometers. What is the volume of the moon in scientific notation, 3 decimal places in the mantissa? The mantissa is the part that's being multiplied by the power of 10. So like for the Earth down below, 1.1 is the mantissa. So we just need to plug, whoa, what's going on there? We need to plug 1,738, that's our radius, into the original formula here, because we're trying to find the volume of the moon. So let's go over here on my page. We want to find the volume of the moon, knowing that the radius is 1,738 kilometers. Make sure I typed that right, or wrote it right, 1,738. Yep. So then for the volume, we just plug in to the 4/3 times pi and 1,738. I'm going to skip writing the kilometers because I know the answer is going to be kilometers cubed. And so now it's just calculator time. So, Desmos, please get yourself a new line on your calculator. And I like that the Desmos keeps track of it. My phone version does that too. 4/3, then arrow to the right, multiply by pi using the pi button, and then multiply by your radius, 1,738, and raise that to the 3rd power using the power button. And in this case, the computer was nice enough to give it to me in scientific notation. So I got 2.1990649 times 10 to the 10th. The instructions here said use 3 decimal places in the mantissa. So then we would take 2.199 as our mantissa times 10 to the 10th. So according to my calculator, this is about 2.199 times 10 to the 10th power, and that would be kilometers cubed. Now some calculators might display that different. Did anyone on their calculator get an E in there?
No, I used the Desmos.
Desmos was good, okay. So I'm going to try it on Google, see if it gives me anything different. 1,738, and there's the power button, to the 3rd. Okay, so Google actually didn't give me scientific notation, it gave me all of those. So then I have to decide where to put the decimal. So this is a good one to look at. So let me screenshot that. So if your calculator doesn't give scientific notation, like this one here, then I have to figure out what to do. In scientific notation, there can only be 1 digit to the left of the decimal, so the decimal has to go between the 2 and the 1. And then I just have to count how many times I have to move it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And usually I count a couple of times just to make sure I got that right, because it's easy to mess up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I already knew it was 10, but my point is here, double check that you're getting it in the right spot. Some calculators, and apparently no one in this crowd right now is having this problem. You might see it like this on a calculator. 2.199, maybe some more decimals, and then you might see an E plus 10. And all that E plus 10 means is times 10 to the 10th power. So that E means times 10, and then plus means a positive 10 as opposed to a negative 10 as the exponent. So again, make sure you're used to your calculator. Don't go switching calculators for the test. Anyone out there use, what's that called? Photomath. My kids love Photomath. Anyone use that one?
Ew, no.
No. All right. So supposedly with Photomath, you can. You just take a picture of what you're trying to solve and it will solve it for you. Can it do anything? And the answer is no, but it does algebra pretty good. So I don't know how helpful it'll be for this class since we don't do much algebra. But it definitely has a good calculator, so it could do that. All right, we're moving along. We got an answer there. What is next? So we'll put that in. The volume of the Earth. Okay, so this time they gave us volume, and they want us to find the radius. So I'm going to use that other formula we came up with. And it says the Earth has a volume of 1.1 times 10 to the 12th kilometers cubed. So let's make a note of that. New page. So for the Earth, the volume is about 1.1 times 10 to the 12th cubic kilometers. And we want to find the radius, so we're going to have to use that other formula we came up with. So the cube root of 3/4 times, let's see, it was the volume over pi is our formula. So we just need to plug into that. And again, if your calculator doesn't have the cube root, I'll show what to do. So I would use the cube root button on the calculator. And sometimes that comes with parentheses. And then I'd have 3/4 times in the top parentheses 1.1 times 10 to the 12th, close parentheses for the numerator part. And then the denominator, we just need a pi, and all of that is inside the root. On some calculators, you would have to enter that same fraction, but your power would be 1/3 for the cube root. So I'm going to enter it into both calculators, make sure I get the right answer. And please try this with me to make sure your calculator is working the way you hope. So Desmos does have a cube root button. And then in there I want a fraction. 3 times parentheses 1.1 times 10 to the 12th. Did I write that correctly? Oops. Check my notes. Yep, 10 to the 12th. Double check the problem. 10 to the 12th, okay. And again, I don't always double check. I should, because I often mess up that kind of thing, mistyping something. And in the bottom, we just have 4 times pi. And if I type that right, I get the Earth has a radius of about 6,403. Let's write that down. That's kilometers. Let's check with the other calculator and double check the instructions about the way we enter it. So in Google, it does not have a cube root button, so I'm going to have to use parentheses with a fractional power. So in here, I'm going to have my 3 times parentheses 1.1 times 10 raised to the 12th power. Close that parenthesis, divide. Here I need an extra parenthesis for the denominator, 4 times pi. Close the denominator, close the whole thing, and then I can raise it to a power. Come on, power, there you go. parentheses 1 over 3. So hopefully I have all my parentheses in the right spots. 6,403. Good. And actually, I guess I should round that up, huh? To 6,404. Yep. Let's fix that. Pen's glitching. There we go. All right, to the nearest whole kilometer. Instructions say what? Assume it's a perfect square, which it isn't, but that's okay. Use at least one decimal place. Okay, let's double check that answer. To one decimal place, it would be 6403.8. Kilometers. Again, don't forget to double check about rounding. All right, so that one was fairly challenging. The next two are a little bit more so. So we have to translate these sentences and fill in the blank. So let's try the first one. Screenshot it for part E. All right, so the Earth is blank times, the Earth's radius is blank times the moon's radius. All right, so if I write that like mathematically, I'm going to use just an E for Earth. E would be equals blank times the moon's radius. Okay, so we got to figure out what multiple we would multiply the moon by to get the Earth. Well, we just divide the moon to the other side. And to figure out what that multiple is, we just take Earth divided by moon. So we just calculated the Earth's radius is 6,403.8. We were given the moon's radius of 1,738. I got to double check those two. So we should just be able to divide to get that multiple. So let's see. The moon radius is, 1,738, and we just calculated the Earth radius was 6,403.8. Yeah, so we have to do that division. So what happens if I take 6,403.8 and divide by 1,738? I get the Earth has a radius that's about 3.7 times bigger. How many decimals would we like? It said use at least one decimal place. So the Earth's radius is about 3.7 times bigger. The next question asks, well, what about the volume? What happens if we compare the volumes? So then we have to take the volume of the Earth, divide by the volume of the moon, because again, it still says Earth first. So we can repeat that same process. So for part D, now EF, sorry, we want to know the Earth's volume is equal to what times the moon's volume. So pretty much like before, we have to divide the moon to the other side. So we want to know what happens if we take Earth and divide by moon. That will tell us how many times bigger the moon is. So let's see, what did we get there? We had that Earth was 1.1 times 10 to the 12th power volume. That was kilometers cubed. And if I make a mistake, let me know. We discovered the moon was 2.199 times 10 to the 10th, I believe. Let's double check the notes. What problem? Earth volume, 1.1 times 10 to the 12th, and the moon's volume is 2.199 times 10 to the 10th. So we have to divide those two numbers. On some calculators, you want to be careful about that, and you may need parentheses around these. And they're both measured in kilometers cubed, but really I just need to get that division right. So try that on your calculator, see what you get. Should be much bigger than the previous answer. So decimals should be easier to do this. First set up your fraction, and then enter your numbers. And I think I have them typed right. 1.1 times 10 to the 12th, 2.199 times 10 to the 10th, and they're in the proper position. So I get the Earth volume-wise is 50 times larger. Holy moly. Okay, that seems reasonable. And to one decimal place, it's still 50. Questions on that calculation? And again, you always double check your work before you submit. As long as I type those numbers right, this seems pretty reasonable from here to here. Earth over Moon, both volumes. Yeah, I think that looks good. And I don't see or hear any questions at the moment. Let's submit for fun. And I got a whole bunch of green checks. Yeehaw. Okay.